Hey guys, so for lesson 2.4, we're going to find the vertex and the intercepts of the parabola. And at this point, everyone should know what the vertex is. If you don't know, you need to go back and look at the resources that I gave you. There's over here a little picture that I put for quadratics unit on the tool section or the material section. I put a little picture that states every part of the quadratic parabola here. So the vertex over here will be the highest value, and sometimes it will be the lowest value. So it's that turning point where the parabola makes that turn. Today in lesson 2.4, I'm not going to go over the do now. I'm going to scroll down and go over the mini lesson over here. So over here it says, how do we find the equation of the axis of symmetry algebraically? So without looking at the parabola, without looking at the graph or using a calculator to put in your function, we're going to calculate algebraically, that means by hand, how to get the axis of symmetry. So you see this little formula over here? This is how you're going to get it. So the first thing you want to do is put your equation or your function in standard form. Sorry. Over here, that's the standard form. I'm sorry, it's looking crooked. This is the standard form. And once you have it in standard form, we're going to identify the A, B, and C. What are the values of A, B, and C? Over here, we have y equals x squared minus 2x minus 3. A is 1, B is negative 2, and C is negative 3. Now we're going to plug it in to the formula over here. So let me see. Over here, I'm sorry. Over here for x equals negative BA. Negative B over 2A, I'm sorry. B over here is negative 2. So if you see over here, they have the negative, right? And they also have the negative of an B. So the formula tells you to put a negative, and then the B is also negative. So over here, if you notice, we have a negative for the formula and a negative for the B. Now, 2, we're going to write it over here, if everybody sees that, and then times A. That means multiply. So 2 times 1 is 2, and then over here, negative 2. So what is negative and negative? These two negatives will make a positive, and then 2 over 2, let's write that second step over here. 2 over another 2 is what? 1. We can try it again with another problem, and you will notice that you'll get the same answer as the calculator will give you. So over here, this equation of axis of symmetry is another way to get your vertex or your axis of symmetry. And again, your answer should always be x equals something. Okay? Because at this point over here, this is the line, that invisible line that crosses what axis? The y or the x? The x-axis. So that's why we have x equals something, not y, or just 1, right? So over here, we're going to scroll down. It says the coordinate of the vertex. Over here, since the axis of symmetry is x equals 1, passes the vertex, the coordinate or the x-coordinate of the vertex is the same, 1, right? So the x-coordinate, like I said, that line that crosses through what? The x-axis. So you know that the x-coordinate is 1. Now, how do we find that y? To find that y-coordinate of the vertex, we're going to substitute the x value into the same function. So we're going to put it into here, like we did here in the model problem, and over here. And we're going to solve for what? What is this equal to? This is equal to y. So if you notice, just look at this equation here. What is the variable of this equation here? Y equals 1 squared minus 2 times 1 minus 3. What is the variable here? The variable is y. So if we're solving here, is for the variable, which is y. We have the x coordinate, now we're going to get the y. If you just plug that into the calculator, 1 squared is 1, minus 2 times 1, which is 2, minus 3 is negative 4. You can put it into the calculator just like that. So this is the way to get the vertex without using the calculator, meaning algebraically. So the vertex is 1 from the first one here, 1, comma, negative 4. Okay. Determine the maximum or minimum value of the function. In the given equation, over here, the leading coefficient is 1. How do we know? This x squared has an invisible 1 right here. 1. Since a is positive, the parabola opens up, meaning a smiley face, and is the lowest point of the graph, and its vertex is the lowest point. So the vertex over here will be a lowest point, right? It will have a minimum value, not a maximum. Therefore, the function has a minimum value and occurs at the vertex 1, 4. The minimum value is 4. So why do we get the 4 and not the 1? So let's put a graph on top of this. Over here, 1, 4 would be, I cannot make a straight line. This is the x, and this is the y. So look, the vertex over here is 1, 4, right? Now, the minimum value always, let me get another color, always is measured by the y-axis over here. So at this point, if you look at, I'm trying to make a dotted line here. If you look at the y value over here is what? 4. What's the x value over here? 1. So 1, 4, which is the vertex, which value do we want? Do we want the x value, like the axis of symmetry, or do we want the y value, the one that goes left and right? We want the y value. That gives us the minimum. And that's where we get 4 over here. Okay? So we can check all of our answers by looking at the graph of a function. So what does that mean? I can check my answers by just plugging it in here. We say on, and we go to y equals, and we're going to put it into the y equals function. And then you're going to find your minimum value. This is another one here. Okay, we're going to find the minimum value. You're going to look at your table, your x and y table, and you're going to see that your vertex over here is 1, 4, right? Over here, 1, 4. So I just put it in, and if you can notice here, you can't really see the graph. If the graph, nope, it's not going to focus. So I see over here my graph. Oh wait, the vertex is 1, negative 4. So over here, I think this is a typo. The graph actually looks something like this. Negative 4 would be somewhere down here. So 1, negative 4 is somewhere down here. So if you go like this to parabola, your y, or your minimum, would be touching 4 right here, which is negative 4 over here. So that is 1 comma negative 4. So your minimum value, how did I not notice that? Over here is 4. But your y value is negative 4. Okay. So I'm going to look at the decimals because my camera is not picking up my calculator here. So when I put the function here, again, I'm going to see my vertex over here. And let me put myself smaller. And I'm going to see my vertex, which is 1 comma 4. Does everybody see it here? And also over here, remember that rainbow effect that we were talking about last time? How do I know where's my vertex over here? I see that negative 3 over here matches with this negative 3. And this 0 matches with this other one here. And 5 matches with this 5. So that 1 comma negative 4 is my vertex. Okay. If you have any questions, please let us know. Let us know in the comments, or if you want to use the Google Hangouts chat, I have invited everyone to chat with me. You just have to accept the invitation, and any specific questions that you have, you can just ask me there. If you want to do a Zoom meeting, like a one-on-one meeting, don't be afraid or shy to do it. You just have to message me, and we'll do a problem, 5-minute problem together if you want. Okay? So see you later.